Python comes with many built-in tools that you have already seen and will learn more about later. However, these tools alone are not enough for programming. That's why Python provides many pre-installed libraries containing additional modules. These extra modules are not automatically available in our Python program. To use them, we need to import them into our program using the import statement. This statement loads only the specific modules you need into your program. You might wonder why Python doesn't make all libraries available at once. Here are the benefits of manually adding them to your program. Modularity and efficiency. Python's modular design allows code to be broken down into smaller, reusable parts. Importing only the necessary modules keeps our programs efficient and lightweight. If all modules were loaded automatically, it would waste memory, especially for large libraries with many functions we don't need. Avoiding name conflicts. Without explicit imports, Python would have to search through all modules, which could lead to naming conflicts. By importing only the required modules, we avoid ambiguity and conflicts. Selective usage. Not every application needs every available module from Python's vast library. The import statement allows we to choose which specific parts of the library to use. This selective approach keeps our code focused and clean. Resource conservation. Loading unnecessary modules consumes memory and other system resources unnecessarily. Python follows a lazy approach, only loading modules when explicitly requested. If we don't need a particular module, it's better to leave it untouched and not waste resources loading it. Before we dive into the import statement, let's understand what Python modules are. Modules are reusable pieces of code stored in separate files with a .py extension. If you think of libraries as a toolbox, modules are the actual tools inside. Modules group together related functions, classes, and variables. This organization makes our code more manageable, especially for larger projects. Python has a large collection of built-in modules in its standard library. These modules help with various tasks like math operations, file handling, networking, and more. We don't need to reinvent the wheel. By importing a module into your program using the import statement, we can access and use all the functions and variables defined in that module. Even better, we can choose to import only specific parts of a module instead of importing the whole thing at once. Now, let's go back to the IDE to see how to use the import statement in practice. The import statement, typically placed at the top of the code page, can be used in two main ways. Firstly, we can import the whole module. Here's the basic syntax for the import statement. Import module name. In this case, module name is the name of the module we want to import. For instance, if we want to generate random numbers, we don't need to create and define functions from scratch. We can simply add the random module to our program. Import random. We imported the random module into our program. This module provides functions for generating random numbers, mix-up sequences, and other random operations. Importing modules in Python doesn't require adding .py at the end. After importing a module, we can use its functions by typing the module name followed by a dot and the function name. For instance, to use the randint function from the random module, we would write it like this: random.randint from 1 to 100. Here, we're using the random module to access the randint function. This function creates a random whole number between 1 and 100. Then, we use the print function to show the generated number as output. Sometimes we only need a specific part of a code module, like a particular variable or function. Instead of importing the entire module, we can import just the part we need. The way to do this is from module name import component name. For instance, If we want to use the pi constant from the math module, this is how we do it.
From math, import pi.
Print pi sign equal, comma, pi. We used pi without needing the math module because we imported pi directly from the math module before running the print function. We can import multiple things on the same line. For example, by adding a comma after pi and typing e, we can import the e constant into the program as well. We can give a module a nickname to make it shorter or easier to use in our code. We do this using the as keyword. For instance,
Import random as rd.
Print rd dot uniform 3.2 7.8 as argument. Now, rd is a nickname for the random module. We can use rd instead of random to use its functions and variables. For example, we use rd to call the uniform function, which gives us a decimal number between 3.2 and 7.8. One benefit of using aliases is preventing conflicts between variable names in our code and variables within imported modules. An alias for the module allows we to use a different name, avoiding confusion and mistakes. If we don't import a module in our program, Clipchamp warns us before Python runs the code. It shows a red line under the module that hasn't been imported. When we hover our mouse over this line, a message, unresolved reference math, appears. If we overlook it, Python will give an error after running the code. When this error occurs, Python explains that the module math we used without importing it isn't defined. It will also suggest that math may be the name of a Python internal library that we forgot to import. This error message helps us quickly identify and correct the mistake. To run the code without errors, we need to add the import statement. Or we can ask the IDE to do it for us, which is easier. The IDE can help us do this. Just hover the mouse over the error and choose the Import Math option, or simply press Alt-Shift-Enter. This automatically inserts the necessary import statement. One cool feature of Clipchamp is that it can automatically import modules for us. Just type the function name and press Enter, and Clipchamp will handle the import. In Clipchamp and similar editors, if we import a module and then press Ctrl while clicking on the module name, it opens a new page. This page shows us what's inside the module, including definitions and possible documentation. Let's take the math module as an example. As you can see, at the start of this file, there's a note about providing mathematical functions based on the C standard. As you scroll down, you can see all the variables and functions included in the module and how they are defined. We can also go directly to a component. For instance, if we press Ctrl and click on exp function, it will open the math.py file and show us where exp function is defined. The import statement isn't just for Python's built-in modules. We can also use it to import our own custom Python scripts and modules into a program. Let's look at an example. For instance, let's say we have a module called calculator that we've already created. Double-clicking the file will open it. As the name suggests, this function takes a number and returns its cube. To keep things clear and save time, we'll skip the nitty-gritty details of how this module and function work for now. We'll dive deeper into that later. We're going to use this custom module in our main script. Just like before, we'll import the module at the start of the code. No extension needed.
Import calculator.
Next, we use the print function to call it and give it 5 as an input. Print calculator.cube 5. We run the code, and it works perfectly. Because the calculator.py file is in the same folder as main.py, it was easily found and imported without any issues. This time, unlike previous examples that used built-in Python modules, We added our own custom module and used its components just like the others. The examples you've seen so far have shown the basic usage of the import statement. We'll use this statement a lot. The import statement has some more advanced uses that we'll explore later on as needed. Importing modules in Python is a great way to reuse code and add more features to your programs. But remember, it's important to use imports correctly and follow good practices to keep your code organized and easy to maintain.